Hello, you absolute legends. We are on PhET.colorado.edu website, and we're going to build some models of small molecules and talk about the electron domain and molecular geometry. Now, to find this website, I just go into Google and type in PhET, P-H-E-T, and it's usually the first hit that comes up, colorado.edu. It's really an amazing, fun website to play around with, really for a lot of ages, but also a lot of sciences. There's a lot of physics, quantum mechanics, biology, and stuff going on in there. So we're in what's called molecular shapes and real molecules or model. So in this model kind of sandbox right here, we can start with just a central atom, and we can kind of just add stuff to it. So for example, here we have a central atom, and for this example here, we don't know what this atom, this could be anything. Let's imagine this carbon in the center, and we're adding CH4. So this is a molecule, CH4, carbon in the middle, hydrogen on the outside here. What I want you to try to get out of this right here is just the three-dimensional look of it right here. Okay, when we draw our Lewis dot structures, we don't get three-dimensional structure. We have to imagine it. We can kind of see like what's in behind, what's in the front. Okay. I'm trying to line the molecule up right here. There we go. So this molecule is trying to line it up so that way these two are in the plane of the computer screen. This hydrogen atom is going behind the computer screen away, and this is coming toward the computer screen. Now down here, we can predict the molecular geometry and predict the electron geometry, and then click and unclick it kind of as a self-test. So this carbon atom is surrounded by four things. So if anything is surrounded by four things, 1, 2, 3, 4, it's going to have an electron geometry of tetrahedral because it's surrounded by four things. Now each of those four things happen to be bonds, and there are 0 lone pairs, so we're going to have molecular geometry also of tetrahedral. Now this tetrahedral geometry is a Greek, like solid Platonic name right there. But a couple ways to think about this geometry is that it's a square-based pyramid, like here. I'm sorry, it's a triangle-based pyramid. It has 3 triangles at the bottom there. I also sometimes like to think of this tetrahedral geometry as like a flower. Like here's the flower stem, and here is the flower itself. Or an umbrella that you've opened too far is a way to describe the tetrahedral geometry. And because there are no lone pairs, electron and molecular have the same name. We can also get some bond angles, 109.5. Kind of fun bond angles, but again, we're talking about 3 dimensions, not solid space right here. If we're just talking about the bond angles of these 3, but we're not. We're talking about these 4 in space right here. Let's build another one. Let's take out the bond angles. And this one, let's do ammonia. Now this is nitrogen, NH3, with a lone pair on there. Oops, meant to unclick those. We'll just imagine we didn't see those. So we have NH3, small molecule. We have it. So this molecule is surrounded by 4 things. And when anything is surrounded by 4 things, it has the same tetrahedral electron geometry because the electron groups are 4 electron groups. Now its molecular geometry is when we're not concerned about the lone pair here. The molecular geometry is trigonal pyramidal because we have a triangle-based pyramid right here. So a little different right here. This molecule is surrounded by 4 things. So it's tetrahedral electron geometry. 3 of those things are bonds. So it's trigonal pyramidal. That lone pair pushes those 3 things down to form the triangle-based pyramid there. Now, these bond angles angles. It's a tetrahedral electron geometry. And we have these bond angles around 109 again. Let's start over again. Put a double bond on there. Let me unclick again. So here we have, we have carbon in the center right here. We have formaldehyde. Formaldehyde. We have a carbon in the center, a double bonded oxygen on the top, and hydrogens right here. So this is formaldehyde, CH2O. It is surrounded by, let's look at its three-dimensional. It's a flat planar thing. It's kind of like a ninja star. It is surrounded by three things. 1, 2, 3 things. I understand that there's a double bond here, but it's all counting as one thing poking out. So it's going to have a trigonal planar electron geometry. Trigonal because there's three things, and then planar because it's all flat. Now, if you recall when we had the CH4, when everything around it was a bond, the electron geometry and molecular geometry were identical. Same thing here. This is surrounded by three things, and they're all bonded to atoms, so the molecular and electron geometry is the same thing. Now for the bond angles, we can click on the bond angles, and we see 120 degrees all the way around. That's a real intuitive number. We're talking about things on a plane, so 360 degrees divided by 3, 160. I hope this helps. Thank you.